So today we'll see the design of the knuckle joint. As we know, the knuckle joint is again one more simple machine component as like the design of that of this quarter joint. So in last lecture we finished the design of that of this quarter joint. Basically that quarter joint was used when it is subjected to tensile and compressive stress in axial direction. Similarly, we have one more joint, that is the knuckle joint. Knuckle joint is a mechanical joint used to connect two rods which are under tension load, or which are subjected to the tensile load. It is not used for connecting the shaft, rotate and transmit the torque. Again, as like the quarter joint, this knuckle joint is also not used for connecting the shaft that rotate and transmit the torque. And here the knuckle joint is a mechanical joint used to connect the two rods which are under tensile load only. Different applications of the knuckle joint. Knuckle joint found the application between the tie bars in a roof trusses, joint between the links of suspension bridge, joint in a valve mechanism of reciprocating engine, fulcrum for levers, and joint between the link of the bicycle chain. These are the different common applications we found where the use of knuckle joint. Now we'll see the some of the photographs where the application of the knuckle joint, so that it is very clear to you the use of the knuckle joint application in day-to-day life. So here, so this is the link of that of this bicycle chain. So where this is the one form of that of this knuckle joint. So double I, single I, and this is the pin. So that is connected. That joint is nothing but the knuckle joint. This is again one form of that of this knuckle joint. So double fork and the single I are connected with the help of the nut and the bolt. Similarly, here is a joint, so which is again the knuckle joint. Two rods are subjected to the tensile load, are connected by the knuckle pin, and in your vehicle also the same form of that of this joint we observe. So these are the some common photographs or applications where the use of the knuckle joint we found in day-to-day life. Coming toward the next, the components of that of this knuckle joint. Before going to the design of that of this knuckle joint, so different components of that of this knuckle joints, again as like the quarter joint, here also the three important components of that of this knuckle joint. This is the component called as a fork end, also called as a double I. This is the component which is called as a single I, or simply the I end. This is the component which is called as a knuckle pin. Okay, and this is the component which is called as a collar for the pin, and this is the component which is called as a taper pin. Sometimes this taper pin is also replaced by the split pin. So that three components along with that of this split pin, so these four are the components of that of this knuckle joint. Out of these four components, three components we design. We can calculate the different stresses, we can check the design stresses, or we can calculate or we can confirm the dimensions of that of this knuckle joint. The split pin, the main function of the split pin to avoid the removal of that of this pin from the assembly. So also we can use a taper pin. So as we know, the taper is provided for the tightening of that of this pin in that hole. If the taper is provided, so it is easy to remove from that of this assembly. Also it gives the, that means proper fixing or proper tightening in that hole of that of this pin, so that it can prevent the locking arrangement, or we can say the pin cannot be removed from the assembly if it is properly locked either by taper pin or the split pin. Next, this is the diagram, or we can say the neat diagram or label diagram. Okay, so label diagram of that of this knuckle joint along with the different notations. So whatever notations we use, so that notations we will use for the design of that of this knuckle joint. In different book different notations are used. So here we'll see the different notations used. So this d is the small d is the diameter of the rod. D is the diameter of that of this rod. Capital D1 is the diameter of enlarged portion of the rod. Then moving towards the that pin diameter, so D1 small d1 is the diameter of the pin. Then D2 D2 is the diameter of the fork or the eye end. D3 small d3 is the diameter of the pin head. Then T is the thickness of that of this fork end. T1 is the not the thickness of the fork end, thickness of that of this eye. T1 is the thickness of that of this fork end, and last T2 is the thickness of that of this pin head. So these different dimensions, or not a dimension, these different notations we are going to use for design of that of this knuckle joint. As already I told, the different book different notations are used, so that you have to make changes in the formulas for the different stresses. So moving toward the next slide, so these notations already I discussed. P is a tension in a rod, D is the diameter of the rod, capital D1 is the enlarged diameter of the rod, small d1 is the diameter of the pin, D3 is the diameter of the pin head, D2 is the outer diameter of the eye or the fork, T is the thickness of the eye, T1 is the thickness of the fork end, T2 is the thickness of the pin head, and X is the distance of the center of the fork radius from the eye. So moving toward the different failures, so here 8 to the 9 different failures we will see, so that either we can calculate the dimensions of that of these different components of the knuckle joint, or also if we use the empirical relation. So in the last slide I given the some standard proportions of the knuckle joints, so we can also use that standard proportion before going to the design. And once we assume this different standard proportion, then by using the different design equations, either we can confirm these dimensions or we can give the design check for the safety, so that we can say the whatever dimensions we assume from the standard proportion that are safe for the given knuckle joint. Now one by one we'll see the different failures of that of this knuckle joint. First one, the first dimension we have to calculate, that is the diameter of the rod. And the rod or the when the knuckle joint subjected to the tensile failure or tensile stresses, then the rod dimensions can be calculated. The dimension can be calculated, again it is similar to that of the quarter joint. This pin portion subjected to the tensile force having the circular cross section, and when the tensile force is applied from the both the ends, then we have the tensile equation sigma t is equal to the P upon A. A is the cross section area of this spring portion. As D is the diameter of the rod, then pi by 4 D square is the area, so that unknown D can be calculated. So here from this failure, so we can get the diameter of the rod. Moving toward the next failure, again the as like the quarter, pin is the major component of that of this knuckle joint. And before starting the design of the pin, as I stated in the last class, the material selection. Here also the material for the pin can be selected as a plain carbon steel or the alloy steel. Same is the material for that of this single eye or the double eye. We may select the different material for that all the three components, or we may select the same material for all these three components. Here again the failure of the pin is possible in a two ways. Either pin can fail in a shear failure, or pin may fail in a bending failure. Here two possibilities, again the two possibilities of the failure of the pin. As I told or I discussed in the last lecture, whenever pin is fitted in a large clearance hole, whenever the pin is fitted in a large clearance hole, so the large clearance may cause bending failure of that of this pin. But if the pin is fitted in a finger tight hole, so at that time the pin may fail due to the shear failure. So here the failure figure shows the failure of the pin in a shearing. The portion which is in between the single eye and the fork or double eye is subjected to the shearing failure, as d1 is the diameter of that of this pin. So double shear area pi by 4 d1 square, twice the pi by 4 d1 square, because the double shear. And finally with the shear equation we can calculate the d1, that is the diameter of the pin. So in next slide we will see the bending failure of the knuckle pin. And whenever the pin is inserted in a large clearance hole, the failure occurs, and failure occurs due to the bending failure. And in majority of the cases, the knuckle joint, the pin failed due to that of this bending failure, not the shear failure. Because in most of the this joint, the pin is fitted so in a large clearance hole. So that is our role, designer's role, whether the pin is failed due to the shear failure or the bending failure. So just you have to remember, if there is a no clearance, so at that time pin failed due to the shearing failure, or if the clearance is there or large clearance between the hole and the that pin is there, then pin may fail due to the bending failure. If bending is the failure, this is the equation we can use to calculate the diameter of that of this pin, so by any means we can calculate the d1, that is the diameter of the pin. Coming towards the next failure of the double eye under tension. So double eye is also called as a fork end. So we have the three different failures of that of this fork. Fork subjected to the tension, fork subjected to the shear, and fork subjected to the crushing failure. So here this figure shows the failure of the double eye under tension. Again, when the tensile force is pulled from the both the ends, this is the portion, this shaded portion subjected to the tensile failure. And again with the dimensions, so we have the diameter d2 and the d1 is the pin diameter, t is the thickness of that of this fork, so that is the area resisting in a tension. And finally with this equation, either we can calculate the sigma t or we can calculate the d2, that is the diameter of that of this diameter of the enlarged diameter of the fork or the eye end. Similarly, the failure of the double eye under the shear, the rod or fork end also failed in a shearing failure. This is the portion which is subjected to the shear failure. By calculating the shear area, finally we can calculate the shear stress, or we may calculate the d2. So again from this equation, either we can calculate the induced shear stress or we can calculate the d2, that is the diameter of the, that means fork or the eye end. Similarly, one more failure for the double eye, that failure of the double eye in shear. The portion, shaded portion, that is subjected to the that is subjected to the in a crushing. Sorry, here it should be the crushing failure, not the shear failure. Make it correct. Failure of the double eye in a crushing. So here you have to make it correct. The failure of the double eye in a crushing, because we are looking the crushing failure. Crushing is like a compressive failure, and this is the portion of that of this eye subjected to the crushing. That means we know the pin diameter d2, we know the thickness of that of this fork is a t1. So twice the, that means location, two locations, so twice the area is affected in a crushing, and therefore crushing failure is calculated. So step number 4, 5 and the 6, these all are the failure of the double eye in a shear, tension and crushing. Either from these three steps we can calculate the induced stresses in a tension, shear and the crushing. If these induced stresses are less than allowable stresses, then whatever dimensions we assume from the standard proportion, that are safe. If we put the values of these stresses and if we get the value of the d2, that is the diameter of the pin or the fork end, so that diameter select to the maximum one, from these three, and that will be used for the further design calculation. That means either we can calculate the induced stresses, or we can give the design check by calculating the induced stresses, or we can calculate the diameter. Whichever is the maximum diameter, that will be the diameter for the that component of that of this knuckle joint we will select. So that is for the double eye. Coming towards the next failure of the single eye in a tension. As like the double eye, here also we have the three different failures of the single eye. Single eye failure in a tension, single eye failure in a shear, and single eye failure in a that crushing. So this is the figure where failure shows the single eye in a tension. Again the same kind of that of this failure. This is the shaded portion which is subjected to the area resisting for the tension. So which is equal to the d2 minus d1 into the t, that is the thickness of that of this fork end. And finally with the help of the tensile stress equation, so we can calculate that sigma t induced, or we may calculate the value of the that dimension of that of this eye, that is a d2. Similarly we'll go for the failure of the single eye under shear. Here also this is the portion which is subjected to the shear failure, and again by using this equation we can calculate the induced shear stress. And last failure is the failure of the single eye in a crushing failure. So as like that this a double eye subjected to the crushing failure, this is the portion where the single eye is in a crushing failure or the compressive failure. We know the d1 is the diameter of the pin. The portion around that of this pin is subjected to that crushing failure, and t is the thickness of that of this eye or the fork end. So that we can calculate the crushing stress. P is equal to sigma c is equal to the p upon d1 into the t. Again similar way, either we can calculate the induced stresses, or we can calculate the d1, that is the diameter of the fork end or the eye end. Again for safety, so this allowable stresses should be less than or equal to the permissible stresses. These induced stresses are less than or equal to the permissible or allowable stresses, so that we can say the design is safe. Or we can calculate the diameter and selecting the highest diameter from these three failure, so that we can proceed for the further design. So this is the procedure we use for the design of the knuckle joint. So 8 to the 9 different steps we have to use. From these different steps we can get the dimensions, or we can give the design check for the different dimensions of this knuckle joint. So this is the table. So initially we can select this dimension also. Whenever we have to solve the problem on a design of this knuckle joint, whatever notations we use for that knuckle joint, so for that notation these are some standard proportions we use. So either we can assume these different dimensions of this knuckle joint component by using these standard proportions, and then we'll give the different design check equations. After getting these standard dimensions, whatever equations of the stresses we are going to use, with this equation either we can calculate the induced stresses, or if the dimensions we calculate, then whatever dimensions with this standard proportion, that should be less than these dimensions, or if not, then we can select that this maximum value. Also whatever stresses calculated for the design check, that are the stresses nothing but the induced stresses in a knuckle joint. And whatever induced stresses, it may be the crushing stress, it may be the tensile stress, it may be that shear stress. These all induced stresses should be less than or equal to the permissible stress or allowable stress. Then we can say the design is safe for the given application or the given loading condition. So these are the things that we can use for designing of this knuckle joint. So today we'll stop here. So in next lecture we'll see the problems on a design of this knuckle joint. All of you go through these different slides, recall these formulas or remember this formula carefully. While solving the problems, either first we'll go with the different standard proportions, select different dimensions of that of this knuckle joint. Then we use the different that design equations of that of this knuckle joint, so that finally we can give the design check, or we can finalize, or we can confirm the dimensions that we assume with the standard proportions. So from the examination point of view, the question is again important. So the question is in the form of draw a neat level sketch of the knuckle joint, state the applications. For 4 mark or 6 mark the question may be asked. Also another possibility, draw a neat level sketch of the knuckle joint, state their applications, and also write the different design steps. For 8 mark or 10 mark question may be asked on this knuckle joint. So again, the very important from the examination point of view. So go through the different slides so that you can understand the different design steps and the then standard proportions of that of this knuckle joint. In next lecture, we'll start the numericals or problem or design problems on a knuckle joint and a quarter joint. So thank you very much.